Welcome back, welcome back, welcome back. This is part 5 of the notes for Unit 2 for chemistry class. We're talking about atoms in the periodic table, and we're going to hopefully finish up these notes right now. Okay, so we got to this part. This is something that will be in your homework and on your test, and you're going to get a homework worksheet on it tomorrow, okay? You're going to have a chart like this, and part of the information will be filled in, and you have to figure out the rest of the information. So here is one where it's all filled in. I have the element hydrogen, so its name is written out. Its atomic number is 1, because remember over there, blue number 1. That means atomic number and protons is the same thing, so the number of protons is 1. Hydrogen's mass is 1, and 1 minus 1 is 0, so there are 0 neutrons. So the mass is the protons plus the neutrons, so 1 plus 0 is 1. Does that make sense to you? The number of electrons is 1, because it's the same as the number of protons if it's a neutral atom. And it's an atom, not an ion. And its charge is 0. It doesn't have a charge. Did I give you the charge column at the end? No, you could add it somewhere. Also, the symbol is H. Sometimes I ask for the symbol. Okay, so we're going to do number 2. The symbol is C. So what is the name of the element C? Carbon. Okay, let's make sure I can write. Let's make it a better color. Let's go with red. Okay, so it's carbon. Looking at the periodic table, what is the atomic number of carbon? 6. So what is the number of protons of carbon? 6. What is the number of neutrons of carbon? It's the mass minus the protons. 6, because 12 minus 6 is 6. What is the mass? 12. What is the number of electrons in a neutral carbon? 6. And is it an atom or an ion? It's an atom because it doesn't have a charge, and its charge is 0.
How come it doesn't have a charge?
What?
How come it doesn't have a charge?
Because there was no clue telling us it has a charge. There'll be some that will have a clue to let you know it has a charge. This one doesn't have one.
What? You said number.
What?
I was going to say, what about the neutrons? But I just thought they're neutral, so it doesn't matter.
The neutrons are 6.
No, I was talking about for hydrogen.
Oh, yeah. It doesn't have any. Okay, so let's try the next one. It's number 13. Which element is number 13? Aluminum. So the symbol is Al. The name is aluminum. That's kind of messy, but you can sort of read it. Aluminum. What's the number of protons? 13. What is the number of neutrons? 14. So aluminum is what over there? 27. 27 minus 13. Is that 14? Okay. The mass. What is 13 plus 14? 27. And notice we're rounding it off. What's the number of electrons? 13. And is it an atom or an ion? It's an atom with no charge. Okay, now this is our one that's a little bit different. Yes?
So the same number of neutrons, same number of electrons and protons, they all going to be the same?
They're always going to be the same if it's an atom, but let's look at this one. This one has 16 protons and 18 electrons. So here's our different one. We'll get to it though. Which one is, if it's got 16 protons, what's its atomic number? 16. If its atomic number is 16, which element is it? Sulfur. Does everybody understand that?
Wait, what is the number of electrons?
It was given to us. It's 18. So the symbol is S. The number of neutrons, we're going to look at the mass for that. It's 32. What's 32 minus 16? 16. So our neutrons are 16. Does everybody understand that? Okay. So what is its mass? Round it off. It's 32. its electrons are 18, so it's gained 2 electrons. So does it have a charge? Yes. So if it has a charge, it is an ion. What is its charge? It has 2 more electrons than protons. It's -2. Remember, electrons are negative, so the charge is -2. And the symbol, you put a -2 as a superscript. You add a -2 as a superscript. Not a subscript, but a superscript. Superscript. All right, how do we feel about that? So this one's an ion. So let's do, helium is nothing special, so I'm going to let you do that one by yourself. And we'll do more of those tomorrow for a homework sheet. Okay, let's go on to isotopes. Now, what makes this hard is ions and isotopes both start with the letter I, but they're different. Ion is whether it has a charge. Ion has a charge. So everybody think about your eye and zapping it with electricity. That would hurt, right? So think about ions are charged. Ions are charged. Everybody got that? Okay. Isotopes, not charges. Atoms can have more or less neutrons. They can be fat or thin. So I have 2 cats here, a fat cat and a thin cat. They are both cats, right? Just like if I have an isotope, a carbon atom, that has more or less neutrons, it's still carbon. It's just fat carbon or thin carbon. Isotopes, okay? Some isotopes, especially fat ones, can be radioactive. They get so fat, they fall apart. They got too many neutrons. Carbon-14 is radioactive. Carbon-12 isn't. It's because carbon-14 is fat. They fall apart. They shed particles. They shed radiation particles, the ones like alpha, beta, and gamma. And we're going to do a whole unit on radiation particles. So that's all we're going to talk about of this right now. All right, the next page. I'm going to run over here. It makes great TV when I leave the screen here. And roll this up because it keeps freaking it out. Okay. There are areas to the periodic table. We're going to color a periodic table, but on the test, you're going to have to label the areas of the periodic table, okay? So I'm going to point them out to you briefly, but then we'll do a whole little activity. I'm going to give you a periodic table, and it's going to become your resource that you're going to be allowed to use on some test. So we're going to start by telling all the areas, then we're going to keep adding and adding and adding to it, okay? All right, so the first one is metals and nonmetals. Metals and nonmetals of the periodic table are separated by some stairs. The stairs go like this. So everybody draw this on your periodic table. Darken that right there. Okay? Metals and nonmetals.
What color is that?
The metals, I'm using pink. The metals are over here. And the nonmetals are over on this side of the stairs. So this side is metals, that side is nonmetals. You can see there's a lot more metals than nonmetals. And on your reports, did y'all notice that? Over and over again, y'all said, this is a metallic element.
Is hydrogen the only exception?
Hydrogen has got its own little special thing. A lot of times, hydrogen will be up here floating up top like a demigod or something because they don't know quite how to put it. Yes.
Isn't tennessine a halogen?
Yes. We'll be talking about that too. Okay. So that's the biggest division, but there are others. There's ones that are called metalloids, and the metalloids. I'm going to change my color here. The metalloids are the ones who touch the stairs. So I'm going to draw little lines through them. These are the ones who touch the stairs, and they're metalloids. They have characteristics of metals and nonmetals, including metals are good conductors, nonmetals are not. Metalloids are semiconductors. See how silicon is a metalloid? And the computer industry was born on semiconductors, metalloids, very important to our society. So metalloids are touch the stairs. They're kind of metals, kind of not. The next one is noble gases. I'm going to change my color again. Noble gases, we'll make them yellow. Noble gases is this column right here. And they don't like to react with anybody. They used to be called inert. Now we know if we try hard enough, we can make them react a little bit, but basically they don't react. It's this first column right there. Do you have a question, Tyler?
Yeah. Isn't OG touching the stairs though?
It is. Some of these are more than one thing.
So it's both.
It's both, yes.
So is boron.
Yes. These are things that are more than one. Also, this is how nerdy the scientific community is. We argue about which of these are considered metalloids and which aren't. So different periodic tables will have different ones colored for the metalloids. Yes, we don't have much to fuss about. This is what we argue about. It's a metalloid. No, it's not. All right. Another one is the halogens. I'm going to make them green. The halogens means salt former. So these are things that like to react with metals to make salts. Sodium chloride is not the only salt, and it's this column right here. So look, now that's a metalloid, a metal, and a halogen. That one is a metalloid, a nonmetal, and a halogen. So see how they can be more than one? But this family right here are called halogens. They make salts. And you can remember that because chloride's in it. It's from sodium chloride. Another one is the alkali metals. They are extremely reactive with water, everything else in the world. And they are this first column here. So alkali metals are metals, but they're a special kind of metal called alkali metals. Alkali means basic as opposed to acidic. They don't make acids, they make bases. Okay? The ones next to them are called the alkali earth metals. Let's find a color for them. We'll make them pink. Okay? So this is the alkali earth metals. And this has got calcium, magnesium. They're very reactive too. Okay. Another one, okay, these others here, the transition metals, we'll make them star colored. They are the ones, these metals, that are in this rectangle. These are the transition metals. Not those right there, but all of these in this rectangle that I'm coloring starry are transition metals. Sometimes these are colored other metals, and then those are nonmetals. So also. The actinides and the lanthanides are down at the bottom. Let's roll up and get them. Okay, so notice that it says the L word on top and the A word on bottom here. Those go right here. So the lanthanides, I should change my color. We'll change it to orange. The lanthanides are these top ones that start LA, and the actinides, I don't think I'm saying all the syllables there. We'll make them light blue. They are the ones on the bottom. And those are the regions of the periodic table. On the test, this will be a matching question. I'll have all of these. I'll have these labeled, and you match them. But we're going to color them also. All right? That's Unit 2. Your test on it will be Thursday. Until then, we're going to be doing labs and worksheets, making Bohr models, and all of that stuff. Okay? It doesn't seem too hard, does it? You'll have to know your scientists and their stories, match them to their stories, match them to their model, and then be able to do the chart inside the atom, do the Bohr models, match to the periodic table. Science is great.